going to talk this week about extending the process modeling approach we talked about last week. If you weren't here last week, you don't need to know that approach, but I will recap. As ever, keep your microphones muted. If your version of Teams supports raising a hand and you've got a question, you can do that. Otherwise, type something in the chat, and I'll do my best to answer it. As I said, so we'll make the slides and the video available. So just to recap, for those that were here last week, and for those that weren't, I'm not sure whether everybody was here last week. This is what we call our process ontology, and essentially at the heart of it is the concept that we have process ways of doing things, and processes are essentially made up of activities, the steps that you carry out within a process. Those activities are designed ultimately to produce artifacts, and those artifacts could be, documents, they could be designs, they could be, actual systems, bits of code, bits of equipment. So the things that the processes, actually produce. Processes also consume, although consume's a bad word. Uses would be a better term there. So activities also use artifacts. So, for example, if you're doing a design process, an activity within a design process may use a requirements document, which would be an artifact that's flowing into the process. So processes produce artifacts, and they use other artifacts in that production. And we also have got the concept of stakeholder role. In this case, the role of a person that is responsible for. Now, responsible for is deliberately vague, and it covers a sort of multitude of responsibilities. And again, last week we talked about actually essentially replacing that single relationship with maybe up to 5, and having something like RACIC. So you could have 5 different stakeholders linked to an activity. You could have those that are responsible for carrying it out, those that are accountable to make sure it's been carried out correctly, stakeholder roles that support the carrying out of that activity, stakeholder roles that have to be informed that that activity is underway, or it's been completed, and those that have to be consulted as part of carrying out that activity. So that responsible could actually split out into multiple lines of responsibility. And we've also got the concept of a resource, and our resources do get consumed in the sense that, paper gets used, people's time gets used, electricity gets used, money gets used. So that's what we mean by resources. And processes don't exist, just for the sake of it. They exist because there are requirements, and we always talk about requirements in context for use cases. So there is a context, there's a process context for a set of processes. There's essentially a set of requirements as to what those processes exist for, what they have to do. And in many organizations, as well as international standards, for example, if you look at ISO 15288, which is the international standard on systems engineering, systems and software engineering lifecycle processes, so processes for carrying out systems engineering, they often group processes into things called process groups, which are essentially just, think of them almost like ring binders. All of the technical processes are in one group, all of the management processes are in another group. It's purely an organizational construct, really, just to help the sort of management of the processes. It's nothing more than that. And typically, when it comes to systems engineering, processes realize sort of services. Systems can be realized as physical products, and those physical products can also embed service, and that service might be realized as software, or it might be a system could be an entirely service-based system where it's people, writing things on pieces of paper and sticking it in the post. It's still sort of service-based. So processes exist to realise services. So that's a very, very sort of quick recap of what we did last week. So that process ontology and the concepts around it can be extended to cover a number of related areas. It can be directly extended essentially to cover standards and compliance mapping, standards modelling and compliance mapping. So the exact same approach with that ontology and the 7 viewpoints that we talked about last week to capture process content and structure and behaviour and flow of information and stakeholders, etc. We can use exactly the same approach to model standards, for example, particularly if those standards are process based. So 15288, for example, 12207, they all make really good standards that you can apply the process modelling to. And once you've got standards modelled, either international standards, national standards, or even sort of company standards, your own process models, your own systems engineering processes. When you've got them modelled using the approach we talked about last week, then that's when you can start doing compliance mapping, which is literally sort of mapping one model to another. So it becomes very, very powerful to see how your internal company standards, your internal company processes map onto international standards, ISO standards, things like that. It can be extended to cover because we have stakeholder roles associated with the process, and then those stakeholder roles will have competency profiles defined against them, which detail the competencies that you need to have to carry out that role. So you can start to link in competence. You can link in life cycle modelling, so you can start to think about how you're going to organise your projects and the life cycle of the system, both from a development point of view and post release when it's in service. And that's the topic we're going to focus on today. And linked very closely with that life cycle modelling extension is project management. So taking it as far as looking at actual project plans and structure of projects in terms of organisational structure and organisational responsibility for aspects of projects. But today we're going to look at the extensions for life cycle modelling, and those extensions come in. Jumped ahead too much. Those extensions come in essentially here, and I'm not going to say anything else about that point yet. If I'll come back to it as we flesh out an ontology. So what I'm going to do is I'm going to start again building up some concepts and discuss the concepts around life cycles and life cycle models. But they're going to tie into the process through this new thing called a process execution group, which we've got on this process ontology. So everything else on there, so everything over here is our standard process modeling ontology that we've just recapped and we did last week, and we've added this extension which I'll come back to. So life cycles and life cycle modeling. Well, the first thing to talk about is that we've got life cycles defined. 15288 defines a life cycle. Anybody that does work for the MOD in the UK, they've got a CADMID and CADMIT life cycles. And life cycles define a number of stages that you have available to you. So conception, development, operation, support, retirement, for example. Now, the key thing is in the language that we use in Scarecrow, when we talk about life cycles, these are static, they're structural. There is no timing on a life cycle. Okay? It's purely a definition of stages that you have available to you. And you could break the stages down, certain standards, break them down. And certainly when you're modeling, within an organization, you could break those stages down into sub stages, or at the very least, typically they have things like typical outcomes and typical activity, something like that. So a lot of the standards sort of detail the typical kind of things that you'd expect to be happening in a stage. But the key thing is all cycles are static. They are purely a definition of a set of stages that you have available to you. Now, the really important point on here as well is this link here, this interfaces with, because we have to remember that we may have a company life cycle that we adhere to, and we're working to that. But that's not the only life cycle that is being used. Different organisations are going to be following their own life cycle, and those life cycles potentially are going to have to interface with each other. There's going to be an interaction with them. There are going to be points in your life cycle where you need to interact with life cycles from other organisations. And now I'm bringing in the process execution group that, if you remember, was on this this slide here on the process modeling one. And in fact, I'm going to draw process on here. Process. One or more processes are executed in process execution groups. So all a process execution group is a set of processes that you run, that you execute during a life cycle stage. And then that ties in, if I go back to where I've written sort of typical activities, I mean, I use activities in quotes, and maybe typical processes would be a better expression there. Yeah, leave it like that. So all the process execute set of processes from your process model you typically run in a stage. So it's a way of saying, okay, when I'm in this stage of the life cycle, these are the processes I'd be expecting to carry out. So in conception, you'd be doing things like requirements elicitation and requirements analysis, and maybe some of your design process, and actually maybe some of your implementation and testing processes if you need to maybe test a new piece of equipment or a new possibility that you're thinking about. But and as you move through the different stages, the processes that you execute in those stages change, and the sort of balance of effort changes as well. There are lots of sort of graphs out there. So for example, if you graph, I don't know, say the requirements process, so you've got sort of effort vertically, and you've got the stage, so essentially you've got time on the horizontal axis, but split into various sort of stages. So for example, your requirements effort would, if you're doing your project properly, should tail off like that. It should be most of your work's done up front, but it tails off later on. Now your design is going to peak over here, but it doesn't mean you're not doing any here. You may be doing a bit of design early on during conception and to test things out, and it's going to peak, and again it's going to tail off. So we see these common sort of graphs where each of those lines is a different process. Acknowledging that within these process execution groups, within each stage, you are potentially running lots and lots of processes, but the emphasis on the effort is different. It's trying to get away from the classic mistake and the classic project management Gantt charts that still get produced where, people do a life cycle, or they use a life cycle, they create a life cycle model, which we're going to come on to next, and it's a waterfall thing, and they say, okay, we're going to spend 6 months doing requirements and 6 months doing design and 12 months doing implementation. And the reality is none of us actually work like that. In that initial stage, you're going to be doing some requirements, you're going to be doing some analysis, you're going to be doing some design. And that's why most modern standards like 15288 and even if you look at what the MOD does with CADMIT and CADMIT, they've gone away from having stages called requirements, analysis, design, 2 stages called conception, development, because they're acknowledging that actually in the conception stage you're not purely just doing requirements. So that's all those process execution groups are. They are typical sets of processes that you would expect to be carried out in each stage. So that's how the life cycle modeling starts to link into the process modeling. We've had a question, I think, from Stephen. Have a look. Is the fault with the Gantt chart visualization or the way it's typically used? It's the way it's typically used, Stephen. No, it doesn't, because if we had twice the amount of time to do this presentation today than we have, we actually use the approach that we're talking about here, and we model from our stages into another sort of level within a stage, ultimately that ends in the process execution groups. So we model a sort of multi-level thing, and we can create our Gantt charts based on that, and those Gantt charts reflect the actual processes that we do through time. So it's not the Gantt chart that forces waterfall thinking. I think it's just typically the way that they're used. Okay, so this is how the sort of process, the life cycle sort of ties in. It ties in through this concept of bundling processes together into execution, things called process execution groups that get executed during a stage. Okay, so we're going to extend it a little bit more now. So the first thing here is the concept of a gate, and a gate is a sort of point in time. Normally, it's at the end of the stage. Not always. I mean, we've got a gate assesses the execution of the stage, and we've got one. I mean, it could be one or more. Sometimes like 1 or 2 gates. Sometimes we have mid-stage gates. But the gate is the sort of formal assessment point, the decision point, typically at the end of the stage, and depending on how that stage has gone, the gate determines what you do next. So possibilities that you often see are continue. So the decision might be to continue. You move back to the next stage. You might have redo. Now that might be redo the stage you're in, or actually go back and even earlier and redo a previous stage and carry on. You could have suspend or hold, and that's when actually you're going to stop. You're not cancelling a project, but you're going to actually suspend work on it while you go and do some investigation or make some decision. So it's sort of just putting the brakes and saying, hang on a minute here, there's something we need to go and find out. We can't commit any more efforts at the moment, but we're not. And then there is cancel. I guess like redo, you can also have repeat as well. So that's a sort of redo, but that's just the current stage, whereas redo can be any stage. But you can have cancel, and that really is, cancel the project. And sort of personally, in my own experience and things I know, projects that I've been involved in and projects I know about, I personally think that decision should be made far more often than it is. But that's a different story. Maybe we'll talk about it in the social afterwards. Okay, so we've got life cycle and stage and the execution groups and the gates, the formal decision point associated with the stage where you decide whether you're going to continue to the next stage, redo a previous stage, suspend the project, cancel the project, or repeat the stage you've just done. Okay, But as I said, the life cycle in the language that we use is purely static. So that brings in the concept then of the life cycle model. And the life cycle model is behavioral. This is the actual set of stages selected from the life cycle. So just because a life cycle might list, 6 stages, 5 or 6 stages that are available, conception, development, or whatever, you may not, as an organisation, have to be involved in all of those stages. So you may only be doing conception work for somebody, for example. You may not ever be doing any development. So you may not be involved in all of the stages. So the life cycle model is now the actual stages from the life cycle for an actual project that you're working on, or a system that you're developing, with timings on. So through time now. So this is the key thing. It shows the order of execution of those stages. It shows the stages you're going to do, the order that you're going to do it, and also you can put timing on as well. So in how you can spend in each stage. And like I say, if you actually take your sort of structure down, you can put how long you're going to spend in each process execution group, and in each process, and ultimately in each activity within the process. And that's how you can actually get your Gantt chart out of something like this. So the life cycle model is behavioral. So when people talk about, what's the life cycle for system X, what they probably really mean is the life cycle model, because what they're talking about is those stages with sequencing and with timing on them. And because, life cycles, different life cycles that are being followed have to interface with each other, because you're part of a bigger project that's following its own life cycle, and your subcontractors are following their own life cycles. Each of those levels, those life cycles, are going to be described through time with life cycle models. So those life cycle models have to interface with each other, have to interact with each other, because the life cycles are having to interface with each other. So that brings on the formal sort of kind of concept of what we call life cycle interaction points and life cycle interactions. So again, the interaction point is static. It's part of the sort of static model. That is saying, okay, this life cycle here interacts with this life cycle here, or interfaces with this life cycle here, and these are the sort of points at which it has to there has to be an interaction where that interface has to take place, and then similarly when we move to the behavioural side, here, move on to the behavioural side, on the sequencing of the different life cycles, you join those interaction points together, and you can see the actual interaction between them. So the concepts we've got here, firstly they split and make the distinction between structure and behavior. So what life cycles, what is the life cycle that we're going to follow? What stages does it have? What processes are we going to follow in that stage? So the how are we going to sequence those stages? How much time are we going to spend in them? And then how is our life cycle going to fit in with the life cycles above and below us, so that we know where those formal interactions are? And this addition of acknowledging about these interactions can be absolutely crucial to the success and failure of projects. We all know that I hope everybody knows, that projects, do follow multiple life cycles. It's very easy for us though to just focus on our own sort of company life cycle and forget that, the bigger picture has got its own life cycle, and the smaller pictures have got their own life cycles, and that those things need to interact. And if you miss those interactions, because it can be complex, if information doesn't get shared when it needs to get shared, or there's an interaction that's been forgotten about. I was involved with a company a couple of years ago in the railway sector, and it was the same company, same project, a big system, two different parts of the company now, each sort of following the same life cycle, but with different timings because the two different parts of the system that they were developing, but they hadn't acknowledged that there needed to be any interaction between those sort of two halves of the development, and it meant that sort of crucial interfaces and crucial design information wasn't shared when it needed to be, and it caused a massive delay on the project. So it's very important to actually think about these interactions. So that gives us our extended ontology with that link through the process execution group to the rest of the process modeling ontology. So following our usual approach, again, that those of you that were here last week, or those of you that have been here faithfully, we should have longer service medals. I think Peter and Fide certainly and Stephen certainly deserve them. That have been here sort of every week and know very, very well that we base our approach to model-based systems engineering on having that kind of ontology in place and defining viewpoints, snapshots, filters onto that ontology that you can then use to create the views, the things that you do in the day job, the actual instances of those viewpoints that document how you're working. And it's no different for the life cycle modeling thing. We've got that ontology, and we actually then add on 4 viewpoints to cover those areas. So we have, the life cycle viewpoint. This is purely about allowing you to document your life cycle in terms of the stages that make it up. I haven't included the process execution group. You can do so. You can extend it if you want to include that, and we would, but for some people have that as a sort of separate viewpoint. But essentially, you've got your life cycle viewpoint. It's a structural view. It's a static view. It identifies the stages in the life cycle, and like I say, if those stages are broken down further, or you can add on, like I say, sort of typical outcomes, lists of typical processes or typical activities, they can be definition. This is taken from Stumpy projects intelligently, which I mentioned last week. It's our very, very stripped down version of 15.288 that we use for teaching purposes. So the life cycle view, so this is an actual instance now for an actual life cycle, it is often not much more complex than that. As I say, you might have extra things in here. You might have fewer stages or more stages, but generally it's at that level of complexity. The next one is the life cycle model viewpoint now. So that covers this part of the ontology. So this is about actually showing. This is about showing the actual stages through time. So this is about sort of sequencing them together, and we would have that at its simplest. We would have it as a sequence diagram. So this shows for this particular project is Project X or System X, that we're going to go through those stages. And on here now we might put timings on. So we're going to spend 6 months in conception. Then we're going to move into development, and we're going to do 9 months in development, or whatever. We can put timings on for how long we're going to spend in each stage. What we would actually do when we're modelling it now, so we would, because we've got, if you remember, we've got process execution groups associated with each stage. So there might be 3 different process execution groups associated with conception. we would now draw another sequence diagram for each of the stages, and the lifelines wouldn't be stages, they'd be the process execution groups with a name. And we do the same thing. We'd sequence them, and maybe something's going to get looped, and it's going to happen a number of times, and then maybe it's going to come back. And then similarly, because process execution groups are made of processes, each of those groups we would break down as well into another level where the lifelines would be the actual processes within them now. And again, we can put timings on. And if you want to, so these are processes. Processes are made up of activities. You could actually either break it down another level or put the activities on the lifelines. So you can put your timings down at this low level, how long you're going to spend in each process. You can aggregate them up to tell you, how long you're going to spend in each process execution group. You can aggregate that up to tell you how long you're going to spend in each stage. So you can sum the timings on there, you can sum the timings on there, and that gives you the timings on there. So, and if you think about a SysML sequence diagram, you sort of turn it on its side, you've actually got a Gantt chart. And that's how we produce our Gantt charts in Scarecrow for projects. We model our life cycle like this, from stages through process execution groups down to processes. We put timings at the lower level and we aggregate them up to give us the timings at our top level. So that's what a life cycle model view would look like. It's behavioral, it's sequence through time, and it's got timings on it. The interaction identification viewpoint is essentially, it's focusing on identifying those life cycle interaction points. Another so we're showing the stages in a life cycle. So we're using a package, as you can see, to represent the life cycle. The stages are listed within that package. And here we've got 3 different life cycles here that all have to interact. And we're putting these, we're using these stereotype dependencies to show that for example, the deploy stage in the acquisition life cycle has an interaction point with the store stage in the deployment. So it has to send something into the store stage of the deployment life cycle. And similarly, there's feedback the other way, that when in deployment it gets to close, it has to fit in back to the deploy stage of the acquisition life cycle. Essentially, what is the stages there of this deployment life cycle carried out by company X are taking place within that deploy stage of company Y. So you can start to put where there have to be formal interaction points. So you can start to understand where these different life cycles that have been followed by different organisations or different organisational units. It may be within one big company. It may just be that there's different units that are following them. The points at which there have to be interaction. And again, on a sort of full example, we'd also have associated with this interaction point there'd be documentation in its description that actually sort of described what that interaction was. So it wouldn't just be a line on a diagram. There'd be descriptive text. So when we output this with all of the text, it tells us what the nature of that interaction is, not just that they're connected. It tells us what's needs to be passed. And then that brings us to the final viewpoint, the interaction behaviour viewpoint. So that's now focusing on essentially capturing those actual interactions on life cycles. So that's back again to essentially multiple ones of the sort of life cycle models. And don't forget, these are going to actually have timings on them here, months or whatever. There'll be timings on this diagram, but it's actually telling you the point in time at which that interaction has to take place. So there'll be a timing on there. there'll be a timing between that and that. So these will have timings on. And again, I've simply stereotyped them here with just the stereotype interaction. But on a real project, you could name the messages with what gets passed across that interaction. So that's the vehicle. Let's say we're building a vehicle. That's the vehicle that actually gets sent across as part of that interaction between the deploy and the store stage. So we would still annotate this with timings. It's turn those static interactions off that diagram where we've got the interaction point, so we know deploy has to interact with store. It's actually showing the point in time at which that interaction takes place now, and as I say, we can annotate it to say, and it might be more than one thing, but we can annotate it to say what goes across that interaction. So what this now enables us to do, if I'm company Y following that acquisition lifecycle model, now I know at that time, because I've got timings all down here. There's timings here, there's times here, there's timings here. I can work out, at that point in the project, in 6 months' time or 9 months' time, we're due to be sending the vehicle to the deployment organisation for them to store it prior to putting it into service. So it allows you, when you're thinking about how your life cycle and your life cycle models, these viewpoints allow you to think about that and formally capture it, so that essentially what you're doing, you're defining organizational interfaces in terms of the way different aspects of the same project at different levels need to interact one with another, which is why, unsurprisingly, this has a massive part in the project management extension we're not covering this week. This is a sort of key part of that. So that's the point of these extensions. They're there to force you to think about, what life cycle, am I going to follow? What kinds of things do I need to do in each of the stages? And then, what order am I going to do them? What timings am I going to put on them? And that can, as I say, be a really useful input to the Gantt chart. I'll come back onto that in a moment, because we've got a few minutes left. But it also forces you, more importantly, to think about the fact that you've got interactions, and what is the nature of those interactions between your life cycle and somebody else's. And then when you're running the project, at what point in time does that have to happen, and what do you need to send across? Because, as I say, that often gets neglected or gets missed, which can lead to all kinds of problems on projects. Now, I said, we model, our things like this, and we put timings on, and we go down as far as the projects, and we can roll that all up. We put it in Microsoft Project. We can essentially, they are 3 levels of a project. So in our Microsoft, in our Gantt charts in Microsoft Projects, we have our top level, our stages, then our process execution groups, and then our processes. As I say, sometimes we go down as far as activities. And the benefit of that is, if you go down as far as activities, go back to that one. Activities are related to stakeholder roles. So what that means now is the resources that appear on our Gantt charts aren't the names of people. They're the names of stakeholder roles, because we know what stakeholder roles involve, because we know the activities that are in the process. We know the processes that are carried out in the process execution groups. We know the process execution groups that are carried out in the stages. So we know in every stage of the project through time what stakeholder roles are involved. So we can get a resource figure, not for people, which I often see on Gantt charts, the names of people, or job titles, but we can actually see the loading on roles. If you got something that says you need 200% of a modeler, and you've only got one person that has got the competencies to fulfill the modeling role, you're in trouble. So we always have stakeholder roles as the resources that are carrying it, not people's names, because it's those roles that have to be filled. The other thing as well is it starts to tie in through the competency. These stakeholder roles are going to have a thing called a competency profile associated with them, and that competency profile is made up of a number of competencies, and they have to be held at, each one has to be held at a level for that profile that goes with that role. So now from my from my project plan, which I'm developing from my deep life cycle model, I not only know the stakeholder roles that I need and the loading on them, I actually know the competencies that are needed by my staff to carry out the activities as part of my project. So it turns essentially a Gantt chart from fairly random that a project manager's come up with, where the names of the tasks and the activities or whatever don't bear any relation to the processes that you're following. It actually turns into something that ties really, really tightly in with your processes, in with the competencies that your staff have got. So it makes that project planning side of things so much more detailed and real, so much more tied to the way you actually do things as an organisation. Okay, so that's all I want to say today. I hope you've found it of interest. If you have got any questions, I've got a couple of minutes. Otherwise, we'll finish. Don't forget, in 15 minutes, we have our MBSE social. We just hang out. You can ask further questions on this. We can rant about the state of the world or whatever. It's basically just an opportunity to have a chat with things tangentially related to model-based systems engineering or systems engineering in general. So if you're free to join that at 11, please come along. That would be nice to have to hear from you. We haven't decided yet, but next week may well be our final lockdown presentation. I don't know. It'll be 13 weeks next week, so it feels a quarter of the year, which is terrifying. It feels possibly like a good point to end, but we haven't quite decided yet. So look out on LinkedIn and for the announcement for what's happening next week. There certainly will be a presentation anyway, even if it's the last. But no final decision has been made, but it may well be the last one next week. So we've got Stephen's asking another question. How do project managers, PMs, interact with the model when you're generating the Gantt charts? Yeah, we can talk about that at 11. Yes, yeah. Is it a discussion point? Yes, I guess it is. Yeah, how the Gantt charts relate to our model. Yes, that would be a good point to talk about at 11. Okay, well, if we've got no questions, I'll end there. As I say, I'll make the slides and the video available hopefully by the end of the day. So look out on our YouTube channel for the video, and go onto our knowledge base to download these slides. Thanks everybody for joining us, and stay safe all. Bye.